Okay, let us discuss, then it will be clear. So, so 1 minute, it's opening. So, I think we were discussing that 2021, right? That one, right?
Right.
Yes. Okay, so some of the identities we saw, right? The binomial identities we are seeing, right?
Right.
Yes. So, yes, so problem number, I think this we are doing 21.
Right.
Yes. So, let us try to attempt it.
Sorry?
Yes, let us try to do it now. So, this problem number 21, this was not complete, right?
Right.
Yes.
So we're supposed to use one of the binomial theorems?
Yes, yes. Binomial identities or binomial theorem, you can use it. So maybe you can copy this again in a new page. Yes.
But like, how would I know which one it would apply to?
Yes. So that will that you have to think. So that is the problem, right? So that you have to get an idea how to use the binomial coefficients, right? Okay. Let us see the problem again. So 20 balls are there, right? So and they are tossed independently and random into one of the five bins, right?
Right.
Okay. So then. Uh, then they're saying that P is the probability that some bin end up with three balls and other end up with five balls, and all other three bins have four balls each, right?
Right.
So first, how many? So we can choose. We can have three bins with four balls, right? So that
Yeah,
is
so that
how
means
many?
so that wouldn't P be equal to, or no, I thought P would be equal to 3.
No,
No?
no. P is no. P is not three.
No. So P over Q would just be P, right? Or is there multiple ways Q is possible?
No, no. P and Q will be fixed. So P and Q are the P is the probability that is end up with three balls, and Q is the probability that every bin ends up with four balls. So P and Q
So,
probabilities are fixed. Then you have to find P over Q. So that is the next step.
so I know, but like the question, so wouldn't Q just be 1?
Mm, why Q will be one?
Because every bin has to have 4 balls, so there's not really.
Okay, but there are different ways how you can choose, how you can keep the balls, right?
So okay, so then wouldn't Q be 5?
Mm, why? Okay, can you explain why you are thinking Q is five?
Yeah. Um. So it's just how many ways you can arrange it.
Yes, yes. How many ways it's you have to arrange that? So that is the idea. Yes.
But like, how many? Like, can you list out like possibilities where it's 4 balls each?
Yes,
In
yes. So that we can do it. So let us try to do that Q part first, right?
yeah.
Okay. So the thing is, so suppose you have a bin, right? So there are five bins, right?
Right.
So each ball, it has five options to go, right? It can go into the first bin, second bin, third bin, fourth bin, and five bin, right? Any one it can go, right?
Right.
So the first ball has five options. Similarly, the second ball has five options. Then the last ball also have five options, right? So total there are 20 balls. So
So
there
5
are five,
20.
right? So there are 5 power 20 ways how we can arrange the balls into the bins, right?
Right.
So this is the total number of ways, right? Okay. Uh, okay. So now we have to, so this is the denominator. So if you know probability definition, so the total number of ways comes in the denominator, right?
Right.
So this is the total number of ways. Now I have to figure out how this how this arrangement is coming, that every bean has exactly four balls, right? So Q is a probability. So Q will be nothing but something divided by 5 power 20. So this is the denominator. So you have to find the numerator. So what is the numerator?
Wait, why would Q be 5 power 20? Isn't that the total amount of possibilities?
Yes, yes. So that is the denominator I'm saying. So Q is a probability, right?
Oh,
So
right. That's of Q, not the entire thing.
yes, yes.
So then, so wouldn't that be 5 to the power 5 times 5 to the power 4 times,
Mm,
no, 5 to the power 5 times 4 to the power 5?
no, why you are thinking like that? Tell me.
Because if you throw, like, let's say, there's like always going to be a 1 in 5. Like on ball 1, it's going to be 1 in 5 chance. On ball 2, it's going to be 1 in 5 chance. Or I
Yes,
guess you can, or you can, I guess you can have like 6 balls in one, right?
yes. But the Q, the probability that we are trying to find out is that every bin should have exactly four balls, right? So that restriction we'll have, right? So here we cannot have freedom on the balls, right? Because I am giving a restriction that every bin should have exactly four balls, right?
Right. So
So
on the first 4 balls, then there's a 1 in 5 chance, right?
yes, but the thing is, balls are independent. That means balls are tossed independently. So the thing is, you have to choose four balls out of these 20 balls, right? Which four balls are going into the first bin, right?
So 20 choose 4,
Right. So that will be 20 choose four, right? So the first bin is done. So now how many balls you are left with?
16 choose 4. No,
Right.
16. Oh,
So
yeah,
next
16.
for the second bin, you are choosing from the 16 balls that is left, right?
Right.
Four balls.
So 12 choose 4.
Right. Up to how much it will go?
8 choose 4. And
Right.
then, yeah,
Four choose four, right?
which is 1,
One.
right?
Right. So this is the numerator actually. So Q is nothing but this whole thing divided by 5 power 20. So now it is clear.
Yeah, I'm just like not very familiar with doing the 20 choose 4 part. Like you have 20 balls and you're choosing for like
Right.
so so in the so this wouldn't this work for the first one where you have 20 balls and then uh you're first choosing 3 balls, then choosing 5 balls and then
Yes,
4
yes.
balls.
P probability will also calculate like this only. Yes. So let us simplify this one first. Q. Yes. Can you tell what will be the simplification of the numerator? So some integer will come. So it will be not complicated like this one. So can you simplify?
Simplify this. Okay.
Yes, the numerator.
Is there like an easy way to do this?
Easy. Actually, the most of the terms will get cancelled. You just apply the definition of 20 choose 4. Then you will
Oh,
see that most of the terms will cancel out with the other things.
Wait, what's exactly supposed to cancel? Do I?
Yes, you tell me. So 20 choose 4, if you apply the definition, what is the thing?
It's going to be six. It's gonna be 16. No, sorry. 17 times 18 times 19 times 20.
No, no, no. Don't expand like
Divided.
that. You keep it in factorial. They don't will be easier to check. So,
Oh, sorry. 20 factorial divided by 16 factorial over 4 factorial
right,
times 4 factorial.
right. So, yes, keep it like this. Now let us expand the second term. 16 choose 4.
16 factorial over 12 factorial uh times 4 factorial.
Right. Then the next term.
Uh 12 factorial over 8 factorial times 4 factorial. Oh, I see how this is.
Yes. So, alternate terms, you can see that it will cancel out, right? So, finally, what will
Do they
remain?
make these problems so that they cancel out
Yes,
evenly?
yes. So, that is otherwise it is difficult to do the computation, right?
Right. Otherwise, it'll take too long for the
Yes.
problem.
Last one is 1 that we know.
Right.
Yes. So, now if you cancel, what are left?
So it's, yeah, those two, and 8. So 20 factorial over
So, all the 4 factorials are left. But how many 4 factorials are there?
4. So 4 factorial squared.
5, right? Power 5, right? So, there are
Oh,
5
5.
things.
Not squared. 5, yeah.
Right. So, there are 5
Wait,
things. So,
aren't there only no, never mind. 5, yeah.
right. So Q, what we got after simplifying is this one, right? So Q is nothing but, so it's 20 factorial divided by 4 factorial whole power 5, and on the denominator I also have 5 power 20. Let us keep like this. So that's why they I've asked to find P by Q. So something from P will also cancel out. So we'll see later. So now let us compute the P part. So P part is 3 balls, 5 balls, and 4 balls, 4 balls, 4 balls. Right. This is how the bins are arranged. Right. Right.
Right.
The denominator is same, right? Because probability total number of ways is still 5 power 20. So what will be the numerator?
Uh, 20 choose 3,
Right.
17 choose 5,
Right.
and then 13 choose 4,
Okay.
9 choose 4, and then 5 choose 4.
9 just 4. Okay, but it is not correct, right? Because
Oh, wait,
some mistake you did. So 17 minus 5 is how much? 12, right? It is not 13.
oops, yeah,
Right.
okay,
So now simplify it like the Q thing.
right, so, okay, I'll write it down. 20 factorial, 3 factorial. So it's 20 factorial
Okay.
divided by 3 factorial
Yes.
times 5 factorial times 4 factorial cubed.
Right. Correct. Everything else is got cancelled, and it is further denominator is fixed to 5 to the power 20. Right.
Right,
Okay. So this is my P. This is my Q. Now let us try to simplify it. So I think that is not difficult.
right.
So now if I want to calculate P over Q, then right. So yes, both you can see that have 5 power 20. That will cancel out, right?
Yeah, so,
Yes. Can you simplify P over Q? Do it on your copy. That means then it will be easier. Just 20 factorial will also cancel out. So only
yeah,
few things
that's
will.
yeah, isn't, wouldn't it be just 3 So it's going to be 3 factorial times 5 factorial divided by 4 factorial squared.
No, that will go in the denominator, right? Because it is
Oh,
check the numerator and denominator.
oh sorry. Yeah. Wait. Yeah. It's 4 factorial divided. Yeah, sorry. 2 factorial squared divided by 3 factorial.
No, no, 4
No,
factorial
4
square.
factorial squared, sorry. Divided by 3 factorial times 5 factorial.
Yes, after this you have to I think expand and simplify. Now there is no else, right? So they just brute force and do the simplification.
Okay, so it would be 20. 590. Wait, 20. Okay.
Okay, so I think one more thing we have to add into this consideration. So the thing is, so here I think one thing we have to more add into the numerator. So this is the number of ways how we have arranged this particular thing, right? Right,
Right,
but there can be an arrangement between them, right? So which bean is getting the five balls? So that is there is one more option for that, right? So this is a particular for particular arrangement you got this combination, right? But
right.
for this, I'm assuming that the first box or the first bean is getting three balls, right? But these three balls can be any one of these
So
five,
wouldn't that just be multiplied by 5?
right? Multiply by five, and what else? I have the same thing about the five number, right? So this will be times five, and similarly, the second option that is that will have four more options, right?
Yeah, and then that's 3 and 2.
No, no. Remaining thing is are fixed, right? Once I have chosen which one is
Oh, right,
three and
right.
which one is
Because,
five, then the remaining things are fixed. So it is just times 15. So here one factor of 15 will come. Yes, now I think you can do it.
right. So you can do that. So it'd be 4 factorial divided by uh, 2, which should be 12.
Hmm. No, I think you check it clear. One more. Let me write down. So it's 4 factorial times 4 factorial times 15 divided by 3 factorial times 5 factorial. Right?
Right.
Okay. So 4 factorial and 5 factorial I can cancel. I get 5, right?
Yeah.
Similarly, 3 factorial and 4 factorial I get cancel. I get 4.
Yeah.
Then this I can cancel.
I said 12, right?
Okay, okay. You said 12. Okay. So then that is fine. Yes. 1 minute. Let me check. So you have 3 factorial, 5 factorial. Oh no, no. So here is a mistake. So 4 times 5 it is 20, not 15. So that's why I was thinking. So this is for 16. Okay.
Okay.
So P over Q is 16. So according to this problem, right?
Right.
So this problem is clear, right?
Yeah, I feel like understanding the choose part will take a bit more practice.
Yes, yes. So it will do more. You have to do more problems, then you'll get a hold of it, right?
Right.
So that is fine. Okay, let us do the next problem.
Okay.
Let me copy the question. Yes, can you see the problem?
Yeah.
Right. So let us see what is saying. So inside a right circular cone. So you know, right? What is a right circular cone?
Sorry. Right circular cone is a cone where I think there's a cone and then the height, like the line from the base to the height makes a right angle. I don't know.
Okay. Yes, yes. So cone is that is fine. The base of the cone is circular, right? So that part is clear, right?
Yeah.
And okay, so yes, I think more or less your definition is correct. So this you have. Sorry,
Yeah.
it got missed. But anyway, it will not come like that. Okay. So if you have this thing, so this is perpendicular, right? So this is the right circular cone, right?
Right.
Okay. So this is the right circular cone. Don't definition is fine. So they have told the information. Base radius is 5 and the height is 12. So this thing is this height is 12 and the base radius is 5. And the three congruent spheres with radius r, right? So inside a right triangular this cone there are three congruent spheres with radius r, and also one more condition that each sphere is tangent to the other two sphere and also tangent to the base and side of the cone,
Okay.
right?
Right.
So they're asking what is the radius of that sphere possible, that radius r they're asking to find out.
Okay.
Yes, so I think they have given a picture. Let me copy that picture. That will be easy to visualize the problem.
Oh, like that.
Yes. Yes.
And is that like is it would it be symmetrical or
Symmetrical in which sense?
like it's perfectly around the center of the uh what is it, cone?
Yes. So the thing is, all the three spheres are identical, right? So three congruent spheres we are taking, right?
Yeah, I
And
understand that.
yes, and we are putting the spheres as that they are tangent to each other, means they are don't intersect. So they are just touching each other. Uh, the individual spheres also the side of the cone and the base of the cone, all of them are touching.
Or okay, so that means that there's like it would be like an equilateral triangle, like with the
Mm,
centers of the spheres.
yes, yes, yes. That will be an equilateral triangle. Yes, that you can say.
And so the each of the sides would be like 2r.
Two are, yes. That also I think we can say yes.
And when it says tangent to the side of the cone, it means it's touching the side.
Yes, yes. It is touching the side.
So wouldn't that triangle be basically inscribed in the circle, in the base?
Mm, yes, the triangle will be inscribed in the base. That is fine. But how? But it will be not exactly the triangle in the equilateral triangle you are saying, right? So, for example,
Yeah,
this. So here you are saying that will form some equilateral triangle like this, right? That you are saying.
right.
Yes. So that will be that you can, if you see from a overview, means if you are seeing from a top view of this thing, so that will be inscribed in the base. That is fine. Uh, but the size of the circle of the base is larger than that. So what I want to say is, so this is the, suppose the base, if you are looking from the top, then the
Okay,
triangle is like this, right? So it is not
right.
touching the sides. So that is what I wanted to. Okay, I will take the screenshot of the top view also. That will be clear for you. So if you are looking from the top, it will look like this.
Okay.
Okay, so this is the equilateral triangle. So X, E, and Y. So these are the centers of the spheres. If you look from the top, this is how it looks like.
Okay. Okay. And we're trying to find the radius of the spheres.
Right, right. So, so that is the radius of the sphere that we can put inside like this.
Okay.
Okay, so this is the top view, right? And if you have a side view, so if I cut the sphere, so it will look like this one. So let me paste that also.
Does the problem give us all the pictures?
No, no, no. That will that you have to find. So just since you are doing it for the first time, so that's why I'm showing you the pictures. You have to draw the pictures and get an idea.
Oh wait, I see how we're gonna do this. We're gonna use like the ratio of the height.
Right? Yes. Only information is height is given to you, right? You have to use the
So
ratio of
you're
the height
using
only.
the ratio of the height to the radius.
Yes. So these are the more or less the pictures you have. My pictures we can erase. That is not needed. So this part you can do the workout.
I mean, you could say that. I don't know how they're getting all these square root of 3 stuff.
No, no, don't look at the options. Then it will be complicated. Just do the problem naturally. Then you'll get an idea how to do it. So let us see it.
So the
So
ratio from
yes,
B to C to O to E would be 12 over R.
B to C. Okay. First of all, okay, let us do like this. So here, this total length is 5, right? That I know because that
Right.
is a radius, right? Okay. So what I get is AE plus EC. So that is 5, right?
Right.
Okay. Now what you told, that is fine. So this EXY, so this triangle EXY, so that is an equilateral triangle, right?
Yeah.
Okay. So C is the center of the circle, and C is also the centroid of the equilateral triangle, right?
Right.
So this length also you've noticed, that is 2R, 2R, and 2R. So then, can you tell me what is the length of this EC? The same. If C is the centroid, what will be the length of EC?
Length of EC?
No, telling length of EC. Yes, yes, length of EC.
R times the square root of 2? I don't. Never mind.
No,
No.
equilateral
No.
triangle there is a formula, right?
Right, right. I'm trying to remember.
Yes.
Oh, it's the
Okay.
30, 60, 90. Never mind. Yeah. Okay.
Mm, yes. The equilateral triangle. First, tell me what is the altitude or height formula. So if you have the side length, what is the height formula? Height of the
Height of
equilateral
the.
triangle.
Oh, but can't you just use the 30, 60, 90 thing?
30, 60, 90 means.
Like, E would be 30 degrees, right? The E, no, E, if you have a point in the middle, like,
Hmm. Okay. This whole thing is 60. 30. Which one you are saying? Yes, so by basic thing, I'm just asking. So we'll do this problem because this is needed. So the thing is, this is the equilateral triangle. You have side length A, and A. So this is the height, right? So in terms of the side length, we have some height formula, right? So height is this root 3 by 2A, right? So this is the formula of the height, right? This you know. Your mic is mute. I can't hear you.
Oh, you couldn't hear me. I was telling you. Okay.
Yes, your mic was mute. Yes.
No, I know. I was saying that it's a 30, 60, 90 triangle.
Which one is the 30, 60, 90 triangle?
If you just make a if you make a cut a line from C
Hmm.
bisecting the EY, it
Okay.
becomes 30, 60, 90 and
Yes, yes. So this one you are saying, right? If I join it.
yeah.
Okay. So 30, 60, 90. Okay. So then how does it help?
Well then uh you basically um R over the square root of 3 would be the base.
Why? The base is the bisecting, right? So this part is R, right?
Yeah.
Yes. But you still don't know this length also you don't know, right? How it
No,
will
you
help?
do. It's isn't it R over square root of 3?
Okay. So you're using the angle formula, right?
Yeah.
Okay. So this is 30. Okay. So then what is EC? Using the Pythagoras theorem.
EC?
Yes. I want to find EC, right?
Oh, EC. Okay, then EC would also be uh EC would be 2 R over the square root of 3.
Right. So yes, that is our EC, right?
Yeah.
Yes. Once we have EC, right. So EC part we found out. So this part is right. So then can we find out the other thing? So the thing is now what we have to find is AE. AE we can find in terms of R, right? Because EC we have found in terms of R.
Right. So yeah, so we found EC. So A is 5 minus 2R over square root of 3.
Right. Yes, that we can use, but we will try to find out AE differently so that we can use this equation to find the value of R. Okay.
Okay. What's so we're looking where would A be on the top view, the edge?
AB. Yes, yes, this is the cone. So this is the side view. So this view is the side view. So you are cutting a cross section along the figure, and this one is the top view. Okay. So now I think you told previously we can use this ratio of the sides. So if I extend this line,
Yeah.
and suppose it meets somewhere here, suppose the point is here, right?
Yes.
Okay. So now if I compare these two triangles,
Yeah, then
AEF and the bigger triangle ACB. So then what we can say about the ratio? So these are similar triangles, right?
right. So you can write so that's 12 over 5.
Okay, so this one is 12 BC.
12 over 5 is equal to uh or you can just write 2.4 is equal to 2R over square root of 3 divided. So it would be 2R over square root of 3 divided by 2.4.
AE, A. K, but the thing is whether it will be helpful. So that is the thing you have to think. Mm. Okay, so if I join this line also. Okay, so let me tell you. So this one, so OE over OF, right? So if I compare this, this is nothing but is same as AE over AF, right?
So you can say 12 over 2r 2r over square root of 3 is equal
Hmm.
to EF divided by AE.
Yes, but the thing is, EF divided by AE. No, that is. Can you say that because we are just comparing these two triangles, right? This triangle I am comparing, and I'm comparing the bigger triangle, right?
Right.
The thing is, we have to have the information. So you are saying AE over which one you are saying?
AE
Hmm.
over EF.
AE over EF, right? But EF length I don't know, right?
Right.
So that will not help much, right? So for finding the EF length, so if I want to find because that is needed. So if I want to find this EF length, I know OE, right? So that is the radius. If I can find OF, then we are done, right?
Yeah.
So that's why I use this one. So here you can see that OF I can find out because I know all these three things: OE, AE, and AF.
Wait, what's OE? Oh,
Yes, yes.
right.
OE is the radius. R. O is the R, right?
Right.
This is R. Now AE by AF, what is that? So by the similarity, AE by AF is nothing but this whole thing by this whole thing, right? By the similarity of the triangle.
Right.
So this is nothing but your 5 by 13, right? So uh, OE is R, so R by OF, so that is nothing but 5 by 13.
Wait, how's it 5 by 13? Isn't it 5 by 12?
No, no, yeah, here see, what is AE? A is this part, and
Yeah.
AF is this part. So if I compare to the bigger triangle, this is AC by AB. AB is the hypotenuse, right? So 5 and 13,
Oh,
the
right, right,
hypotenuse.
right.
Sorry, 5 and 12, the hypotenuse is 13, right?
Right.
Yes. So what will be OF from here?
Um, 13? No.
Yes,
No.
13 R by 5.
Okay. R over. Oh, yeah, 13 RF over 5.
Right.
Right.
So now I think what you are saying that we can use. So we have to find AE, right? So now what ratio you are saying? Tell me. AE over EF you are saying, right?
Right.
Yes, tell me what you are saying. AE over EF is, if I compare with the bigger triangle, what will be that?
It's R. No, not R, sorry. You can just put a placeholder value.
No, no. I'm just tell the ratio. I'm not
Oh,
finding
right,
this.
right, right. It's 12. No, not 12. 5 over 12.
Right, right, what? Right. Now I have know what is EF, right? EF I know. EF is nothing but this is EF. EF is nothing but this plus this, right?
Right. So it's 13R over 5 plus 5.
Right. This thing, right? Now can you simplify what is AE in terms of R?
Yeah, so it's uh 18R
Hmm.
divided by 12.
3r by 2, right?
Right.
Yes, now we can just use this equation. So A is 3r over 2 and EC I know 2r over root 3, right? So that is 5. So from here you can find the value of r. Try to find it.
Right.
Yes, simplify.
Yeah. That would be uh. So that would be five times. Okay, 10 root 3 is equal to. Let me write this down.
Yes, write it down. It will be easier.
Mm, Yeah, it's. What are the answer choices?
Yes, you tell me. We'll see the answer. So what is the r you are getting? Simplifying.
Well, I'm not getting a nice number. I'm getting like 10 root 3 divided by 3 root 3 plus 4.
Uh, okay. Okay. Let us do the simplification. It is not that much difficult. So you have 3 by 2, 3r by 2, and 2r by root 3, right?
Yeah,
So the LCM is 2 root 3, right? So here you get 3 root 3r plus 4r, right?
right. Then 10 root 3 r.
Right. So r if we take common, so it's 3 root 3 plus 4, right?
Yeah,
10 root 3.
yeah, that's what I got.
Okay. So yes, now we have to rationalize. We'll keep the
Oh, rationalize it. I thought, is that a thing where you have to do it?
yes, yes, because usually the thing is we don't keep any root things
Okay,
in the
okay. I
denominator.
understand. I understand now. Okay.
Yes.
So multiply by square root of 3.
No, no. This the conjugate you have to
Oh,
multiply.
where yeah, right, right. I understand.
Yes, tell what will be there now.
It will be it will be uh 40 root 3
Hmm.
minus 30. No, not minus 30, sorry. Minus yeah, minus 30. No, minus sorry. Minus minus 60
Mm, okay.
over over 16 minus 27. Wha- How is it negative? Wait.
Yes, that is fine. Means we can adjust it.
Yeah.
No, the first of all, what you told, tell me the numerator. You told 40 root 3, that is correct. Then what is the second term?
Um oh for 90
Right, 90. You told 60. So that's why. So this is 90, that is correct. Now denominator is 16 minus.
27.
Right, how much is that? Denominator is.
Negative 11.
Right, so you can adjust. So you can make 90 minus 40 root 3 divided by 11, right?
Yeah.
Yeah, so now I think it will match. So here it is, this one, B.
I don't know, like, how are we supposed to do this in 3 minutes? Even if I understood the entire problem,
Yes.
I wouldn't be able to do it in like 3 minutes.
Yes, yes, that is that I can understand. But yes, it will come with more and more practice. So the thing is, first you have to figure out this diagrams or the figures you have to figure out. Then only you can proceed, right?
Right.
So after you figure out these cross-sectional diagrams, so then you can just use the similarity of triangles and compute the ratios, right?
Yeah, the similarity of triangles understood, but I don't know how if I got a problem similar to this,
Hmm.
would I always draw out the cross-sectional diagrams?
Yes, because it is a the thing is this is a 3D figure, right? So this we don't have much information how to control it, right?
Right.
It's always easier to see the two-dimensional thing, right? So that will be easier for us.
Right.
Yes, so that will be easier, so that you can try.
Okay. Like I understand what you did, but I don't know if I'll be able to replicate it.
Yes, yes, yes. That will come. So we are just doing a few classes, so it will come with practice. Right. So let us do one more problem. So not much difficult, but let us do an easy problem. It will be okay. So you know base representation, right? Base representation of numbers, you know, right? Means base
A
two,
little
base
bit.
three. Do you know that?
A little bit.
Okay. Let us see this number. See this problem. So suppose you have a number 9 and its base 9 representation they have given. So it's 27 0 0. So this is given in base 9. So they're asking what is the remainder when n is divided by 5. So this is the question. So I'll tell you what is a base representation. So for example, I'll tell you what is a smaller number. So suppose 273 base 9 is there, right? So then it's 2 times 9 square plus 3 times 9 plus 3, right? So this is the base represent. Like this is you get the decimal, the corresponding number in the decimal
Does that
representation.
work for every base?
Yes, yes, that is so here this is general. So suppose this is base any b, so then is b square b like this.
Okay, right.
So this will be the corresponding number in your the usual number system. That is our base 10 is the usual number system, right? Because
Right.
if you take suppose 25 or 250 in base 10, so that is nothing but 200 plus 50 plus 0, right? That is how we get to 50, right?
Right.
So how will you from this number you have to find what will be the remainder if I divide by 5.
Okay. And is 5 in base? No, 5 can't be in base 9.
No, no, 5 is not. No, in this problem, 5 is not the base. So you have 9 base and the usual one is 10.
Okay. Is this number 23?
Which number?
Number 23?
No, no, no. This is a previous problem because this is problem number 10.
This is problem number 10. Okay.
Yes.
So would it be 3?
Remember, okay, tell me how you are doing.
Well, I turned it into normal numbers.
Yes, tell me. Oh,
So 2 times 9 squared is 162 plus 63.
no, why 2 times 9 square?
Oh, wait, that was just the example.
Yes, yes, this is an example, right?
I didn't do the normal. Okay, okay, never mind.
Yes, yes. So that is an example, yes.
Is there like a fast way to do this?
Yes, the usual way is the first way because see, most of the terms are zero, right? So
Yeah, that's true.
yes,
So I can count the amount of terms, one, two, three. So
so
that,
only the powers of nine
yeah.
you have to make
So
it.
it'd be 2 to the amount of digit, 2 times 9 to the amount of digits minus 1.
Right, right.
So, okay. So 2 times, so it'd be 2 times 9 to the 11.
No, 9 power 10, right?
Hmm?
Oh, sorry. There is one. Yes, you are correct. So one zero is less. Now you can do it.
Oh, okay. 2 times 9 to the power of 10.
Hmm.
Uh, to plus 7 times 9 to the power of 9.
Hmm.
Uh, plus 6 times 9 to the power of 6.
Hmm.
Plus 5 times 9 plus 2.
Right.
So now what I can do, I think, is so 9 to the power of 10
Hmm.
would be, okay, that'd be, so since 9 to the power of 10 is even,
Okay.
would
But
it
you are
would be
checking
ending, if it
divisibility
would
by
be
5, right?
ending, what? It would be ending in, wouldn't it be, so wouldn't the first number be ending in an 8?
Hmm. How can you say that?
Wait, so would I have to calculate this fully?
Yes,
Or,
if you have to find the remainder. If I divide by 5, this number.
so I have to calculate it fully?
No, no, no. That is difficult, right? That you cannot calculate. 9 power 10 times 2. This thing is you have to
So
find a
wouldn't
short.
9 power 10, if 9 power 10 ends in, wouldn't 9 power 10 end in a 9? Like 9 to the power of 10 is some number ending in a 9.
Why?
Well, because doesn't 9 to any power alternate between, like the last digit alternate between 1 and 9?
Yes, yes, that is correct. So since it is even, you are saying that it will end in 9, right?
Yeah.
Okay, so how does it help?
Then then the first number will end in an 8.
Okay, then
And then for the second number, nine's going to an odd
oh,
number, so it's going to end in 1. So the second number
yes,
is going to end in 7.
okay, then
No, it's 7, right?
yes, yes, 7. Sorry. Then
Then 9 to the power of 6 would end in,
9.
right, end in 9. So 4.
1 minute. So mm, no, right? So I think you are doing the opposite one, right? So if it is odd, it will end in 9, and if it is even, it will end in 1, right? Because 9 square is 81. I think you did opposite. So this will be 2,
Oh,
right?
sorry.
Yes, you understood, right?
Yeah.
Right.
So
Okay.
no, what 9 to the power of 4 no, when 9 squared ends in 1, right?
Right. 9 square ends in 1. So
Oh.
every even thing will end in 1.
So it's 2 plus 3 plus 6 plus 5
Right.
plus 2,
Yes. How much is that?
uh 17. No,
Okay.
not 17, 18.
18.
Yeah.
Okay.
So
So if
then
you
wouldn't the remainder be 3?
yes, yes. So 18 we can do. So it is 3 mod 5, right? So yes. So 3 is the remainder, right?
Yeah, I understand how to do this, but I think I had the right approach, but
Yes. This you only did, right? So this is correct. This is you did, right?
Right.
Yes. So yes. So try to do the remaining problems. Then we'll. I think tomorrow the one chess class or something you are heading. That will end. Your father told. I don't remember exactly. So when that will end?
No, not chess.
Uh,
Coding.
yes. Yes. Sorry. Coding. So that has ended.
No, that'll end soon.
Okay. So next week I think that will end, right?
I think so. I'll check and message.
Okay. Okay. Sure. Okay. Then by then you try the remaining problems of the 2021. Okay.
Okay. Okay.
Okay. Bye.
Bye.